Okay. Good morning, everyone. Once again, welcome to the CHaitanya Gosala YouTube channel. I am Amit Bhardwaj, and today we are going to revise some of the important inorganic questions, right? Some important inorganic questions and some of the PYQ also from the inorganic chemistry, right? It will help you in the upcoming NEET exam. Okay, let us start. Okay. Fine. Okay, bache. So, first of all, some questions are coming from our classification of element. Let us see. What is the first question? The IUPAC name of element with the atomic number 119, right? They are saying 119. What is it? NEM, right? What is it? And we have to see, right? It is NEM. Clear? How we write? We write the first number, second number, third number. In the end, we write EM. Right? Easy question. The next thing is identify the incorrect match among the following. If you see carefully, here, this one, EM means they are discussing which one? 111. This is round germanium. It's RG, right? This DEM stadium is 110. That's why this is wrong, right? It is RG. This one is 1110. That's why this match is wrong, or you can say C is the right answer for this question, right? So very important topic, how to write the IUPAC nomenclature for the elements having atomic number more than 100, right? Okay. The next thing is, again they are talking about the element 114. Now you see, remember, from element 104 to 1118, it just matches with the group number. Look at this. This is 4, so match with the 4. 18th group, right? Now they are saying which one? 114. So 114 is part of 14th group only. Directly you can say from here, right? It is 14th group means which one? Carbon family. Carbon family, you will see here, you have carbon family here, and you know that. What is carbon family? It is always NS2, NP2, right? So I am saying once again, from 104 to 118, if they by chance they gave you atomic number and ask group number, so just look at the last number and you can tell, not the last number I will say, look at this, like 114 belong to 14th. If I say 117 belong to 17th, if I say 111 belongs to 11th. This way you can get the group number very easily, right? The next thing is the number of d electrons in Fe plus 2 is not equal to what? Okay. Fe plus 2 beta have how many d electrons? Check carefully. Fe plus 2. Configuration is argon. It is 3d, 6 and 4s0. Right? So it has 6 d electrons. 6 d electrons. But if you check here, in this case, if I check the chlorine is what? Chlorine is 3s2 and 3p5. So it has 5p electrons. But here we have 6 d electrons. That means this number is not same. If I see other thing, like I am looking at the neon. Neon is what? Neon is 2s2 and what here? 2p6. So 6 electron matching. So it is having 6 d electrons, but here it have only how many? 5p electrons. That's why it is the right answer. Fine? Good. The next one is, which among the following is not isoelectronic pair? Isoelectronic pair means having same number of electrons, right? So here we are having, look at this carefully, we have Fe plus 2. Fe plus 2, if you see it's argon, I will say it is 4s to become 0 and 3d how much? 6. Whereas Mn plus 2 is argon, 18 you can say, 4s 0 and 3d 5. Definitely overall it is having 26, not 24 electrons, and it is having how many? 23 electrons. That's why they are not isoelectronic. Both have different number of electrons. Okay. Elements, the correct increasing order of first ionization energy. Fine. You see carefully. In general, when you move in the period or series, ionization energy increase. Why? The reason being size decrease, or you can say Z effective increase. This is the reason behind it. Clear? Now if you see here, but we have some exceptions. Okay, if you check, lithium is okay, lithium is fine. If you go further, there is exception between boron and beryllium. Boron is less than beryllium because beryllium is Ns2, whereas it is what? Ns2, Np1. Because of penetration power and little stable configuration, beryllium have more ionization energy. That's why here you see boron comes before beryllium. This is exception part. Now carbon is okay. Nitrogen is more than what? Oxygen, we know very well. Nitrogen is half filled. That's why extra stability cause little extra ionization energy for nitrogen. So again here we have exception, and then the further going right. Fine, easy. The second thing is, which among the following is wrong in the, according to the given properties? If you check carefully, increasing first ionization energy, just now we discussed about it. If you look, nitrogen, oxygen, nitrogen should be more better because of stable configuration, half filled. And here in electron gain enthalpy, here also we have exception. Here chlorine is more than what? Fluorine. So both are the right one. Here both are not the correct sequences. Both are not the correct sequences, right? Okay, fine. So the next thing, if I say the formation of the oxide ion, first of all remember one thing for this question especially. Whenever you have neutral atom and it takes electron, atom takes electron happily and release energy. So delta H is found to be negative. Means EgE1, electron gain enthalpy 1 is negative, but A negative never accept again electron very easily because of repulsion, negative charge. So delta H2, if I say here, delta H2 or EgE2 is always positive because this negative will repel this negative, or I will say there will be inter-electron repulsion, which will cause we have to push electron to the atom. We are giving energy so that atom can accept electron. So Eg is always positive. So O have first electron gain enthalpy negative, but if we check, second electron gain enthalpy is what? Positive, because O negative start repelling electron. Okay, so what is the reason behind it? You can say that electron repulsion outweighs the stability gained by the achieving noble gas configuration, right? Good, important one. Now they are asking the radii. If you look at these elements, argon, potassium, calcium. If you look at these, all of these have electron how much? 18 electron, 18 and 18. Look at the protons. Here we have 18 protons, 19 protons, 20 protons. So if electrons are same, then we say Z by E more, then size become less. Fine. So by this logic, if you see, here 20 protons are attracting 18 electrons very strongly. More pull, more Z effective will come, and that will cause the decrease in size. So this is the order, right? When electrons are same, protons are more, size become less because of strong, you can say, nuclear force. So which should be the answer? Yes, this should be our answer, right? Good. The next one is beryllium plus 2 is isoelectronic with. Beryllium have 4 electrons, plus 2 means 2 gone. So how many remaining beta? 2 electrons, right? So which is having 2 electrons? Lithium plus also having 3 electrons. Lithium has 3 electrons, 1 gone. So again it is also having 2 electrons. So both are isoelectronic. Easy answer again. Again they are discussing about the size, about the isoelectronic species. Again look at this carefully. If we look, right, look at this. O2 negative have 10 electrons. F negative again 10 electrons. Na plus also 10 electron. But here 11 protons are pulling it. Here 9 protons are pulling it. Here only 8 protons are pulling these electrons toward the nucleus. So more the strong attraction, lesser the size. This is wrong. This is right. Okay. Next thing is, which of these have equal number of sigma and pi bonds, right? We can check it. You look at the structure beta. The structure of XeO4, if I draw here, XeO4. Definitely we have to draw structures for this thing. XeO4 is having 4 sigma and 4 pi. You check here, 4 sigma, 4 pi, it is sp3 hybridized and tetrahedral shape. So here you can see equal number of sigma bonds and equal number of pi bonds, fine. If you check anything else, if I say we are having Cn twice, clear? So if I count here, how many sigma? 1, 2, 3 sigma. In this I will say 3 sigma, and how many pi? 4 pi, not equal. So in this way you can check all the options. The next one is, which among the following contain no pi bond, right? Very important structure, very simple also. Water. It have 2 lone pair, 2 sigma bonds, there is no pi bond. Okay, this is our answer. If you want to check something else like CO2, they have pi bond. SO2 also have pi bond. So easy, okay. Now, which of the following is electron deficient? If you remember diborane, like this is BH3 twice. This is diborane. Here we have the structure. Here we have banana bonds. We call this banana bond, or you can say 2 electron 3 center. It is 2 electron 3 center bond. Definitely hydrogen is trying to complete the octet of neighbor boron also, but they can't complete because hydrogen have only 2 electrons. It can put it here to make the bond, otherwise here, right? So it can't complete the octet, still it is electron deficient. Very important structure, sp3 hybridized, okay, and 2 banana bonds and 4 covalent bonds, or you can say terminal bonds with hydrogen. Definitely it is electron deficient. Which among the following molecule is non-polar in nature? Fine. If you look at the SbCl5, it is just similar to PCl5, right? Trigonal bipyramidal. It's a symmetrical structure without any lone pair. So symmetrical structure is always what? Non-polar and having same atoms. So they will cancel out each other. If you see, the net dipole of this triangular thing will cancel out each other, and these linear or axial things will cancel out each other. So net dipole moment is coming 0. That's why this is completely non-polar. Polar bonds are present, but molecule is what? Non-polar. Fine. Which among the following set of molecule will have 0 dipole moment? Fine. What they are saying, let us see. First they are saying boron trifluoride. Again a symmetrical structure, and surrounding atoms also same na? We have beryllium difluoride, again symmetrical structure, will cancel out the dipole moments of each other, and carbon monoxide, again symmetrical, and carbon tetrachloride, CCl4, right? So easy. I'm saying once again, symmetrical structure with same surrounding atoms. In such cases, dipole moment of one bond will be cancelled out by other bond. Net dipole moment will be 0. Okay, that's why these are non-polar molecules. All of these have polar bonds, but complete molecule is what? Non-polar. Important question. Have same bond order. They are saying which among the following have same bond order, right? Easy to check here. If you see Cn minus also have 3 bond order, and CO also have a 3 bond order. So both have bond order of 3, means 3 bonds in between these two atoms, right? Easy. Consider the molecule. Which among the following statement is false? They are saying, right? Okay, let us see. Fine. If we look at this beta, CH4 is tetrahedral, and CH4 is having bond angle of how much? We know that 109 degree 28 minutes. We know very well that in ammonia we have a lone pair. Because of lone pair, bond angle becomes a little less than expectation. It is almost 107 degree, or I will say 107. And in water we have two lone pair here, right? We have two lone pairs. So in this case the bond angle is 104.5 degree almost, right? The bond angle is maximum where in CH4, then ammonia, then water, right? Now we can check the options. The HCH bond angle in CH4 is larger than the NH bond angle in ammonia, right? It is fine, good. The HCH bond angle in CH4, the NH bond angle in ammonia and H2O bond angles in water are greater than 90, right? All are more than 90, true. The H2O bond angle in water is larger than the HCH bond angle. No, it is wrong, right? It is a wrong answer here. HCH bond angle is more than which one? O, or you can say HOH bond, okay? Easy to find. Which among the following molecule has maximum dipole moment, right? We know very well that CH4 is a symmetrical molecule. Net dipole moment is what? 0. Actually CO2 also is symmetrical, so 0. We have to check which one? NF3, NH3. NF3 if you check, in NF3 direction is little this way. Lone pair pulling upside, F here, F here, F here, right? Whereas in NH3, lone pair pulling upside, here, N is pulling, N is pulling, N is pulling. So net cancellation chances are less here. Because of proper directions, here somewhat cancellation chances are there. I am not saying it is non-polar. Complete cancellation not there, but somewhat cancellation going on. But here cancellation is very less or negligible, you can say, or all of them going in same direction. So they will add up, right? The net dipole moment is maximum for which one? Ammonia here. It's a very important question of NCERT. If I compare the dipole moment of NH3 and NF3, definitely NH3 is more polar than NF3, right? Among the following, which will have the maximum lone pair repulsion? Okay, if you look carefully, here Xc, we have XCF2. XCF2 is a linear shape here and having 3 lone pairs, okay? There are 3 lone pairs, so they will repel each other, and definitely more lone pair repulsion will come here, right? Because of more number of lone pairs present in the molecule, right? In this, if you see, you will have 2 lone pair, 1 lone pair, and you will have 1 lone pair here, okay? Structure they are asking, definitely PCl5 beta. PCl5 is a trigonal bipyramidal, easy to find. SF6 is octahedral with 6 sigma bonds. BRF5 is square pyramidal with 5 bond pairs and 1 lone pair, right? And BF3 is the trigonal planar with 3 bonds without lone pair, right? You can easily find it using VSEPR theory. So if you go for the matching here, the PCl5 is trigonal bipyramidal, SF6 is octahedral, BF5 is square pyramidal, and BF3 which one? Trigonal planar. Fine. The next thing is again structure based thing. SF6, just now we have seen what is SF6 beta. It is octahedral. They are asking wrongly matched. Okay, we know this. It's very well octahedral. BCl2 linear, no doubt. Ammonia trigonal pyramidal. Fine. PCl5 beta, if we check, just now we have seen the last question also. In PCl5, it is trigonal bipyramidal, non-trigonal, planar. That's what is wrong match among the following. Okay, easy question. Identify the incorrect statement related to PCl5 from the following. Okay, remember in PCl5, axial bonds are longer than which bonds? Equatorial, because these feel more repulsion. Okay, so 3 equatorial PCl bonds make an angle of 120, right? 2 axial PCl bonds make an angle of 180 with each other, right? Axial PCl5 bonds are longer than, yes. PCl molecule is non-reactive. No, it is reactive because these two are longer bond. So these two Cl want to break from here easily. Even if you heat the PCl5, it gives you PCl3 plus what? Cl2, right? That's what they are saying. It is incorrect. They are asking the incorrect one, right? Species having bond angle of 120 degree. Okay, again, structure based question, very important. BCl3 is trigonal, planar, and angle here is how much? 120 degree. Fine. Among the following, which is the wrong statement? You have to see here. SEF4 and they are saying SCF4 and CH4 have same shape. Sc beta, if you see oxygen, sulfur, selenium, tellurium, polonium, this is a chalcogens or 16th group. Selenium have how many valence electrons? 6 valence electrons. So if you see SCF4, if I draw SCF4, it will have 4 bonds, right? SCF4 have here 4 bonds, and what is remaining? 1 lone pair. It is seesaw. Whereas if you see CH4 to have simply tetrahedral shape. Selenium have 6 valence electrons, 4 used in making bonds, 1 lone pair remaining, because out of 6 valence electrons, only 4 are used, 2 are still remaining, become lone pair and make it what? Seesaw. Okay, good. That's what is wrong. They don't have same shape. Among the following, the wrong statement. Same question by chance. Which pair of ions is isoelectronic and isostructural? Right? If you see carefully, total electrons here. Carbon how many electrons? 6. Oxygen how many? 6. 6 valence. Total 6 electrons here. Oxygen how many? 8 into 3 here, total electrons if I say, plus 2. In here you see nitrogen how many? 7, 3 into 8 and plus 1. Total electrons are same here, you can check here. Now the structure if I draw, carbonate, trigonal, planar, nitrate, again trigonal, planar. So isoelectronic as well as what? You can say isostructural. Predict the correct bond order. Yes, beta. The repulsion order, sorry. In the VSEPR theory, it's very clearly given that lone pair repulsion is highest, then lone pair, then which one? Bond pair. Easy to find. Lone pair repel each other more, then lone pair, and then bond pair. The maximum bond angle among the following. Okay, let us take the first option, NO2 plus. N plus have 4 valence electrons only, that's why it makes 4 bonds. And here the bond angle is what? 180. No bond angle can be more than 180, be careful about it. So if you see any molecule having bond angle of 180, then nothing can be more than 180. So maximum bond angle is always how much? 180 in our molecule. That's the first answer. Which among the following pairs both species are not isostructural? Fine. If you draw what are these one, if I draw XCF4, xenon have how many valence electrons? 8 valence electrons. So after making 4 bonds, still 2 lone pair are there. Its shape is square planar. Whereas if you draw XeO4. XeO4 to tetrahedral. So definitely both are completely different. It is tetrahedral, it is which one? Square planar. Which among the following pair of ions are isoelectronic and isostructural, right? Again, same type of question it is. You can check. Here we have Cl and sulfur. Sulfur, if you add sulfur 2 negative, you add 16 plus 2 how many? 18, 17 plus 18. O3, O3 same. So both are having same number of electrons, and if you draw structure, ClO3 negative. After making 5 bonds, still we have one lone pair. Here, sulfur again. After making 4 bonds, still it have 2 valence electrons, one lone pair. So both of these are what? Trigonal, pyramidal. Which among the following species has a planar triangular shape? Okay, they are talking about triangular shape. If you see nitrate ion, center atom have 3 sigma bonds only without any lone pair. So what it is? It is your trigonal planar. Easy to give answer, right? The next one is, which among the following is a polar molecule? Okay, if you see beta, SF4, just now we have seen, SF4 is Cisa. It is Cisa. Fine, it is Cisa, and definitely these can cancel each other, but it is not a symmetrical structure, na? They can't cancel out each other, so net dipole moment will come something. There will be some net dipole moment. It is non-zero. It is non-zero. Mu net, if you find, it is coming what? Non-zero. That's why it is not a non-polar molecule. It's a polar molecule, right? A molecule with polar bonds and molecule also polar. These are, if you see here, imagine I am having here BF3 or any other structure you draw. These have polar bonds, but because of net cancellation, mu net becomes 0. So it is a non-polar molecule with polar bonds, right? XeF2 is isostructural too. XeF2, they don't have 8 valence electrons, 2 used in making bond, and here we have this one. So it is linear. This is linear, right? And ICl negative, you see, I negative become 8 electrons, same thing will come, 2 bonds and 3 lone pairs. So both are linear here, right? Clear? ICl2 negative. BF3 is planar and the electron deficient compound. The hybridization and number of electrons around the central atom in the BF3. Okay, if we draw the BF3 simply, BF3 is trigonal planar. Okay, so it is sp2 hybridized and having 6 valence electron. Definitely it is electron deficient and act as a Lewis acid. Okay, easy. So as I said previously also, structures are very important. Structures are very, very important. If you know structure, you can answer many questions: bond order, bond angle, bond length, hybridization, shape, so many things. In our theory classes, we started with the structure only, how to make structure. So it's very, very important. How many sp2 hybridized carbon beta? Here you see this is having 3 sigma bonds only. 3 sigma, 3 sigma, 3 sigma, 3 sigma. All 6 are sp2 hybridized. These are sp. This carbon is also sp2 hybridized. If you check carefully, how? This is like this one, right? This is sp2 hybridized. So how many? 1 and 6. So 7 are sp2 hybridized, and asking number of pi bonds. So how many pi bonds? 3 here, 2 here, 3 or 2, 5, 5 and 1, 6. 7 and 6 you can say. 7 carbon sp2 hybridized and 6 pi bonds. They are asking total pi bonds. So it can be between carbon-carbon or carbon-oxygen. The next thing is the potential energy curve is given. They are asking bond energy. So energy will release. Here the energy gap between A and B. The energy gap between A and B will be released in form of bond energy when you will make a bond between the two hydrogen atoms, right? Hybridization of the atomic orbital of nitrogen in NO2 plus, okay, NO2 plus, if I draw here, this is NO2 plus. N plus have 4 valence electrons, NO2 plus, N is making 2 sigma bonds, 2 pi bond, nitrogen what? Sp. NO3 minus, if you see, NO3 minus this one, 3 sigma bond, what is it? sp2. NH4 plus, 4 sigma bonds simply, so it is sp3 hybridized, right? So you can see option sp, sp2, sp3, easy to find. Otherwise you can apply the formula. What was the formula? Hybridization equals to half number of what? Valence electrons of the atom for which we want to find hybridization, plus number of monovalent atoms. We have discussed it in our class. Number of monovalent atoms plus for negative charge and minus for positive charge, right? You can apply this also. If by chance you don't know the structure, you can apply this formula, okay? Like if I take example, I am taking the NO2 plus, imagine NO2 plus I am talking about here, right? So if you see, if you are going for hybridization, half, right? How many valence electrons on nitrogen? 5. Monovalent atom, there is no monovalent, oxygen is bivalent, right? And charge how much? Plus 1, so what is coming? Minus 1. So 4 by 2 will come, that is 2. 2 means what? Sp. Okay. Which is the coplanar molecule? If you see benzene beta, every carbon is sp2 hybridized. Each of these atoms are present on the board only. Nothing is going inside, nothing going outside. In this you see, this is sp3 carbon, can't be planar. sp3 carbons, these can't be planar. sp3 carbon if present in a molecule, it can never be planar molecule, right? Because it will be inside, outside. It is a 3D structure, na? Here, all are present in this page only. This benzene ring can rotate, but still remain like this. All are in same plane. Next, if you see the correct geometry and hybridization of HCl4. Again, if I draw HCl4, it will have 4 sigma bonds and 2 lone pair. So 4 plus 2, 6. 6 means what? sp3d2. And definitely shape is square planar. Easy to find. Which among the following organic compound has same hybridization as its combustion product? If you look at ethine, in ethine carbon is sp hybridized. If you burn it, you make CO2 and H2O. In CO2 also carbon is sp hybridized, okay? So ethine is your answer. Which among the following is incorrect statement out of the following? Okay, O2 plus is diamagnetic. Check here, O2 plus. O2 have 16 electrons, plus means 1 gone, 15. A molecule with odd number of electrons, so always what? Paramagnetic. That's why it is wrong. A molecule with odd number of electrons is always paramagnetic. A molecule with even number of electrons can be para or dia, it depends. But with odd number of electrons, so always what? Para. Identify a molecule which doesn't exist. If you look at the He2, 4 electrons, if you find its bond order, sigma 1s, sigma star 1s. So if you fill here 1, 2, 3, 4, the bond order in this way is coming what? Half number of sigma number of bonding electron, number of anti-bonding electron, 0. If bond order is 0, molecule can't exist. Like He2, Be2, and E2. bond order 0, so can't exist. Which among the following diatomic molecule has only pi bonds in this? Okay, very important. Be2, if you check, okay, you check with the C2. C2 will have bond order of 2. 2 is a bond order here, and the good thing is in this both are pi bonds. Very important exception. Both are pi bonds. Similarly, if you go for B2, B2 also have only one bond order, and that is pi bond, right? C2 have bond order of 2. There are 2 bonds and both are pi bonds. Remember it especially. B2 have bond order. B2 have bond order of 1, and it is pi bond, depending on the MOT diagram, because here in this bond formation only pi orbitals are involved. That's why it is pi bonds. Consider the following. Which among the following have highest bond order? If you see, Cn negative have 14 electrons and will have bond order of 3, right? That's why it is the maximum here. By the MOT theory also, if some molecule have 14 electron, it will have 3 bond order. If you go further, 15 or 13, so bond order decrease by 0.5, 0.5, 0.5, right? So something is having 14 electrons will be having maximum bond order, right? Okay, look at this. Fine. The decreasing order of stability among the following. If you see, O2 have 16 electrons. So bond order how much? 2. O2 negative have 17 electrons. Bond order how much? 1.5. O2 plus have 15 electrons. So bond order is 2.5. O2 2 minus have 18 electrons. So bond order how much? 1.0. So we can see from here, O2 plus should be the maximum, right here. Then which one? O2, then O2 negative, then which one? O2 2 negative. Fine, easy to give answer. These are almost same only. Okay. So which among the following is paramagnetic? Again, as I said, whenever question come and they're asking paramagnetic nature, so look at the number of total electrons. If electrons are odd, then it definitely is paramagnetic. Like in this case, if I think O2 have 16 electrons, one extra electron become how much? 17. 17 means odd electron and definitely what? Paramagnetic. Without making structure, without making diagram, I can tell this question because it have odd number of electrons. Fine. Which of the following compounds show the presence of intramolecular hydrogen bond? Cellulose is a polysaccharide, right? And in this we are having so many hydroxy groups. Okay, so that's why they can make intramolecular hydrogen bond. These remaining, these can acetic acid can make intermolecular hydrogen bond, not the intra, right? Intra means when the atoms of same molecule make hydrogen bond with each other. That's intra H bonding. Whereas when atom of two different molecules make hydrogen bond with each other, what do we call it? We call it intermolecular hydrogen bonding, right? The correct order of atomic radii, we have exception here, okay? So boron, aluminium, but gallium is smaller in size than aluminium, and then you know indium and thallium, no issue, but here we have exception. So boron is smallest one. Then what is coming? Gallium, aluminium, indium, thallium. This is exception because of poor shielding of 3d electrons. The cause here is poor shielding of 3d electrons. That's why this is the right answer. Clear? Which among the following element is unable to form MF6 3 minus, we should know that second period elements, they can't have more than 4 covalency. They can't make 6 bonds. Second period elements like beryllium, boron, carbon, nitrogen, these elements cannot make more than 4 bonds. Definitely out of these, MF6 3 negative, it have to make 6 bonds, not possible by boron. It can't have covalency more than 4. This way you can go. Okay. AlF is soluble in HF and definitely make this compound, where aluminium can make 6 bond, not an issue. Aluminium can make 6 bond because vacant d orbital are available here, but boron cannot make. The stability of +1 oxygen state among the following. We know that by the inert pair effect, +3 stability decrease down the group. Right? Whereas +1 stability increase down the group. Right? So we know that +1 stability should increase down the group because of inert pair effect. So if we look at this, okay, what do we have here? Here we are going down the group. Aluminium, gallium, indium, thallium. So +1 stability will increase down the group. Okay, you can go that way. Boric acid is acid. Okay, if you see, boric acid or orthoboric acid is H3BO3. If you put in water, it will take lone pair from OH minus and make BOH4 minus, and water is releasing OH here. Water is OH gone with this and H remaining here. So it is behaving as a Lewis acid, accepting accepting OH, or I will say accepting lone pair from OH negative. Right? So it is behaving as a Lewis acid. It is not a protic acid, it is a Lewis acid, right? Which takes lone pair from OH negative in this reaction. So accept OH negative from water releasing proton. You can say that way. Combine with proton, no. Contain, replaceable, no. Give us proton, no. Okay. Now CO is a neutral oxide. BaO definitely very strongly basic oxide. Al2O3 amphoteric, Cl2O7 acidic. Mainly non-metals make acidic oxides and the metals make basic oxides. Some of these makes amphoteric oxide also. But sometime metals in their very high oxygen state can make acidic oxides also, like Mn2O7, you can say that, right? Mn2O7, CrO3. Which among the following is amphoteric oxide? Okay, if you go in the 14th group, if you go for this beta, CO2, SiO2, GeO2, what are these? These are acidic. Whereas SnO2 and PbO2 are what? These are amphoteric. Definitely we have to remember some of these. And the nature of oxide is very important topic from where every time NEET is asking one question. So if you see here, definitely SnO2 is amphoteric, or you can take PbO2 also. Which among the following is not stable? Silicon can make 6 bonds, not a big issue, but it is tough for silicon to handle 6 large chloride ions. NCERT sold example only. Silicon can't handle 6 large chloride ions. It can make 6 bonds, no issue. Here it is stable, SiF6 is stable. But here because of large size of chloride ions, it is not able to handle 6 large chlorides, right? That's why it is not stable. Which among the following is incorrect statement? Okay, if you see the NCERT, they are writing very clearly that SnF4 and PbF4 is ionic in nature. In the 14th group halides, PbF4, SnO4 is ionic in nature, remaining are covalent. Whereas if you see here, PbI4 is unstable because of Pb plus for oxidation state. Okay. So PbI4, you say PbI4 is unstable. I will say one more time. Why? Because Pb plus 4 is not so happy. It want to reduce itself and act as what oxidizing agent. And I minus also want to become I2. So you can say it is because of oxidizing nature of Pb plus 4 and reducing nature of what? I minus. Okay. It is because of the inability of NS2 electrons to, okay, they are talking about here which one? Inert pair effect, right? That's why you should remember, out of Sn plus 2 and Sn plus 4, Sn plus 4 is more stable. Whereas in Pb plus 2 and Pb plus 4, Pb plus 4 is more stable. Inert pair effect we are discussing here. Pb plus 4 want to become Pb plus 2. That's why it want to reduce and act as what? Oxidizing agent. Right? And here we have, it is who is stable? Sn plus 4 stable. So Sn plus 2 is not happy. It want to do oxidation. So act as what? Reducing agent. So Pb plus 4 have oxidizing nature and Sn plus 2 have reducing nature, right? Choose the correct one here. If you look at the structure, diamond, allotropes of carbon. In diamond, every carbon make 4 bonds this way, and further it is making here, every carbon makes 4 bonds. This carbon is what? Hybridized, sp3 hybridized. Whereas in graphite, carbon will be attached to 3 other carbons and having one lone electron which take part in pi bond formation and make it aromatic. So it is sp2 hybridized. In graphite, carbon is sp2 hybridized. In diamond, carbon is sp3 hybridized, right? Because of partial double bond here, you will see the bond length is smaller than the diamond. Which among the following structures is similar to graphite? Bn, boron nitride, is similar to graphite. That's why we call it inorganic graphite. Whereas B3N3H6 borazine is known as inorganic benzene because its structure is similar to what? Benzene. Okay, they are saying the correct statement from the following. Fine. CO2 is used as refrigerant. No, we use ammonia mainly. The structure of C60 contains 12 6 carbon rings. No, 12 5 carbon rings and 26 member rings. So it is wrong. The resin 5 is a type of gyrate used to convert alcohol into gasoline. Yes, it is a catalyst in converting alcohol into gasoline. And CO is colorless, odorless gas. Fine, right? So they are saying correct one. So third and fourth is only correct one, right? Little fact base. Which among the following is not correct about the carbon monoxide? Fine. It reduces oxygen carrying ability of blood, right? Because CO combine with the you can say blood and make carboxy hemoglobin, and it react faster than oxygen with blood, and that's why it will decrease the oxygen carrying capacity of blood, or you can say hemoglobin. The carboxy hemoglobin is less stable than oxyhemoglobin. No, CO react 300 times faster with the hemoglobin and make carboxy hemoglobin. So it is not less stable. That's why it is wrong. Ethylene, EDTA. Okay, EDTA if we talk about, EDTA is mainly 4 negative tetraacetate. There is EDTA 3 negative triacetate, right? If you look at this one, it is like this one, tetraacetate. So it is a hexadentate ligand which donates 6 electron pair, 2 from nitrogen and 4 from oxygen. So it's a hexadentate ligand with 4 O donors and 2 nitrogen donors, right? Easy to answer, very important. The correct order of stoichiometry of AgCl formed with the following. If you look at this carefully, this one, COCl3 5 ammonia. So if already 5 ammonia are present which can act as ligand, so only one Cl comes inside and 2 Cl remains where? Outside. In this case we have only 4 ammonia to act as ligand, so I have to use 2 of the chlorine as a ligands and only 1 Cl outside, right? And in the upper one there they are writing cobalt 6 ammonia are there, so I can use all of the ammonia as ligand, so all Cl will remain outside. So here only 1 Cl, here 2 Cl outside, here 1 Cl outside, here how many? 3. So for this one it will make what? 3 mole AgCl, this makes what? 2 mole AgCl. First one they are saying, that one. It gives 3 of AgCl, it gives 2 of AgCl, it gives which one? 1 AgCl, right? Only outside chlorines are ionizable, inside chlorine are non-ionizable, so they will not give AgCl, right? Very important question from the Werner theory. Cobalt 3 chloride, they are saying, will not give test for the chloride ion. If you look at this carefully, it have only 3 ammonia, cobalt here, we are having ammonia, and here 3 ammonia here, so only 3 chlorine are, I have to use all 3 chlorine inside because only 3 ammonia are present to act as ligand, and we know that cobalt plus 3 have coordination number of 6. That's why to make its coordination number 6 I have to use all 3 chlorines inside only, right? So none of the chlorine is outside which is ionizable and which will give PPT with AgNO3. Easy again, important. The sum of the coordination number and the oxidation number of the metal in the complex, okay? If you see in this case coordination number, first we are finding coordination number here, En is a bidentate, so 2 into 2. C2O4 also a bidentate, so 2 here, total how much? 6. If you go for the oxidation state, X for the metal, En is a neutral ligand, C2O4 oxide -2 charge, and plus of chlorine also how much charge? -1 charge. So X coming from here plus 3, right? So 3 is the charge plus 3 is the charge on metal ion, and coordination by how much? 6, right? So 6 and 3, 9. They are asking sum. 6 and 3, 9. Okay. Look at the next question. You have to write the IUPAC name of this. Both ions are complex ions. Okay, someone is asking, Jaswant is asking, why carboxylic acid does not show position isomerism? Where carboxylic acid can come only at which position? On the terminal position, no? It can't come on the second, third this way. And carboxylic acid has the most priority. So we have to start numbering always from what? First from carboxylic acid. Okay, got the point? This way you can think. Because it comes only at the corner, it can't come inside the in between the chain, right? Okay, bache, let us see. The next thing is the IUPAC name of the complex, AgH2O twice AgCN. Okay, first of all you write the name of complex cation, then anion part, right? What is the name of this? Diaqua. Diaqua, we have two options here. Silver fine, Ag is +1 here, also +1 here. How we can check? Look, AgX, S2 how much? 0. Again AgX, Cn how much? -2. Because 2 na? 0. So X will be how much? 1. So both Ag are 1, 1. Di, aqua, for water, silver 1 for Ag. Dicyanide, as it is an anionic ligand, so end with O. Argentate, why I am using 8 here or I am using argentate? Because it is an anionic ligand, or how much? -1. And oxygen state 1 again, right? Okay, easy to answer. The type of isomerism shown by this compound, okay? This can show a cis trans. If you look at this, if I show M, I have M here, it's A here, it's A. Okay? This is transform according to B and B. Fine? And here I am making, this is cis form according to B. A is a symmetrical bidentate ligand. So these two are geometrical structures of this compound, right? AA is like ethylene diamine and BB is like Cl. One is trans, one is cis. And you should know that this structure to have planar symmetry. This have POS, so it is optically inactive. It is optically inactive, but you will see this don't have any POS and COS. That's why it is optically active. It is inactive, it is which one? Active, right? Clear? Clear, bache? So they are asking which isomerism you can show. Geometrical, right? Coordination, linkage, ionization. Which one? Geometrical. Out of these options. And total, if I say how many? Structure 2. Okay, this one is active, so dextro levo. Total how many? 3 will come, right? For this formula. Okay, the name of the complex beta again hexa. It is hexacyanido. We have hexacyanido. It's a anionic ligand, so I'm saying what? Ferrate. It's an anionic complex, so I'm saying ferrate, not iron, just 3 iron. Okay, it's fine. What is the issue here? Hexacyano first of all is the issue. Second thing is iron, not iron. It's an anionic complex, so ferrate will come. What is the issue here? Hexacyano ferrate 3. Here this is the issue. Okay. Easy. The number of possible isomer. Okay, just now we have seen this. Again the same type, M, AA2, B2 type of isomer. Okay, this will show 3 isomers. 2 structures will form out of 2 structures. One is active, so dextro levo. Total how many? 3 will come. The order of energy absorbed, which is responsible for the color of complex, right? You see, complex will split this way. Complex will split this way. Now electron will jump from here to here. If this split is more, if ligand is strong, this split will be more. Split more means I need a radiation of higher frequency, or I can say radiation of lower wavelength to jump, right? So they are talking about the energy absorbed, right? So stronger the ligand, more the gap, so more the energy required to jump upside in excitation. All strong ligands, here 2 strong, little weak, here 1 strong, this is weak. So definitely I should go for CAB. Strong ligand, more splitting, less splitting, less splitting. Okay. Depending on the ligands. Very important question once again. Number of possible isomers. Okay, same question by chance they gave. The order just now we have seen. Okay, now here we can see they are asking the magnetic moment of the given complexes. Here if we look, F is what? F is +3. F is +3 here, and we have a strong ligand. So I will give one example. You have to solve every question of octahedral complex using diagram of CFT. Don't use diagram of VBT. CN6 Fe plus 3. If you know Fe plus 3, Fe plus 3 is argon. 4s becomes 0 and 3d how much? 3d 5. Strong ligand 1, 2, 3. Strong ligand means pairing 4, 5. How many unpaired electrons? 1 unpaired electron, that means 1.73. 1 unpaired means 1 point something Bohr megaton. FeS2O6. If it is weak ligand, then what will do? In case of weak ligand, we will do this thing. 1, 2, 3, 4, 5. I am not doing pairing because weak ligand means plating will be less, so electrons have more chance to go upside. That's why it will have 5 unpaired electrons. 5 unpaired electrons means what? 5 point something, right? If you go for FeCN6, here is Fe is plus 2. Fe plus 2 means it is 3d6 and strong ligand also. So 1, 2, 3, 4, 5, 6. There is no unpaired electron. So in this case we will have 0 unpaired. That's why this one, right? And definitely this left. So 4.90. Okay. Okay, bache. The strength, but they are asking the strength, right? They are asking strength of ligand by the spectrochemical series. You can see strong, little weak, weak, weak. From spectrochemical series, easily you can see, right? Just one beta, aromatic carboxylic cannot show the Friedel-Crafts reaction because the COH part will react with the anhydrous AlCl3, and this reaction now if AlCl3 is busy in some reaction, then it can't act as a Lewis acid to make electrophile. That's why it can't give the reaction, right? Now we are having here again simple question. If something is sp3 hybridized, it is tetrahedral. dsp to tell us that it is what? Square planar. sp3d is telling trigonal, bipyramidal. d2sp3 or sp32, both are what? Octahedral. Easy. Now what is the correct electronic configuration of the central atom in K4FeCN6? Okay, let us see. If you see, Fe is plus 2 beta here. Fe plus 2. Fe plus 2 means you say argon, 4s0 and 3d6, and strong ligand. You go for the configuration. Strong ligand means large splitting. 1, 2, 3, 4, 5, 6. There is no electron in T2G, sorry, EG. T2G have all 6 electrons, here 0 electrons. So look at the configuration. T2G 6, EG 0, right? Okay. Okay, bache, someone is asking, let me tell you one doubt. I think she is asking, out of Cl and F, which one have the higher electron gain enthalpy? So Cl have higher electron gain enthalpy, right? But if you go for the oxidizing nature, then you see F2 is more oxidizing than Cl2, Br2, I2. So remember, only electron gain enthalpy do not decide the oxidizing or reducing nature. There are many factors, beta. Many factor means I am saying, first of all, you break the X2. You have X2, you will break it, you need bond dissociation energy. Then this X will take electron to become X negative. The X negative jump in water to become X negative aqueous. So here you will have, this is your bond dissociation energy. Here you will have electron gain enthalpy, and here which one? Hydration. So alone electron gain enthalpy will not decide the oxidizing nature of F2Cl2Br2. There are 3 factors. One factor is EGE, in which chlorine is better. but other factor, bond dissociation energy and hydration energy, where fluorine is better. So overall, fluorine will take electron more easily, or I will say fluorine will convert from here to here more easily than which one? Cl2. So on the base of electron gain enthalpy only you cannot decide the oxidizing nature. Okay, it depends on 3 factors. Okay, are we clear now? I hope we are clear now. Okay, now the next thing is NiCO4. 2 times in the NEET question beta, NiCO4. If you look at it, the special thing is Ni is 0 here, means argon here, and you will see it is 4s2 3d8. So 3d8 was like this one, right? But here you are having 2 electron s also. Strong field ligand will send these 2 electrons here and will do the pairing. That's why even it have strong ligand, but it is sp3 hybridized only, because it was Ni0 and 4s2 was here, so these electrons will shift here. So I have to use sp3. So NiCO4 here you see this tetrahedral geometry and diamagnetic, right? No unpaired electron here. NiCN4 2 negative is what? dsp2 square planar, because in that Ni is plus 2, but here Ni is what? 0. Okay. The next thing is again the same question. As I explained, more splitting in the T2G and EG, electron have to absorb more energy to go from T2G to EG. More energy means high frequency radiation and lower wavelength. In this case, they are asking which one? Increasing order of wavelength. So be careful, they are asking wavelength here, not frequency or energy, right? So in which case wavelength will be more when ligand will be weak only, right? This is fine. Weak ligand, splitting less, energy less, wavelength high. Strong ligand, splitting more, energy high, frequency high, wavelength less. In this way we can think, right? Pick out the correct one about MnCN6. Okay, here if we check bachche, Mn is plus 3, Mn is plus 3, so Mn plus 3 means what? Argon, 4s to become 0 and 3d4, 3d4 here carefully, 3d4. So if we look again, diagram will make d4, 1 here, 2 here, 3 here and 4 here, right? So upper is available, so easily ligands will come and make it d2 sp3 hybridized with 2 unpaired electron, right? So it is d2 sp3 hybridized and octahedral. Fine, easy to answer. Okay, so it is the trans effect beta. Trans effect less important. Let us see what it means actually. Imagine this is some structure, here A and here some ligand X. A will be responsible to make this X labile. Labile means it will go and some other ligand will come out of NCERT. So A have some trans effect. It will make X labile, means X will go and something else comes. Imagine Y comes here. It is the trans effect. How much it will make it labile? Okay, it has some order which once in the NEET exam they asked, right? Okay, just order we have to remember here. But out of NCERT I will say, not so much important. But once it came, in classes we have done this, right? The John-Taylor effect again, not in NCERT, so less important I will say. When you are filling the octahedral complex, you will see here you have, if you fill the D8, you see 1, 2, 3, they are saying high spin complex 1, 2, 3, 4, 5, 6, 7, 8. You see T2G is symmetrically filled and Eg also symmetrically filled. When T2G as well as Eg both are symmetrically filled, then there will be no Jones-Taylor effect. If there is any unsymmetry in the T2G or Eg, any of these is unsymmetrically filled, it will have Jones-Taylor effect. What I mean by this, imagine here only one comes. These have 2 electron, it have only 1 electron, unsymmetry. Maybe here it have 1 electron, it have 0 electron, unsymmetry. Or it have 2 electron, it have 1 electron. If there is unsymmetry in the T2G filling or Eg filling, it will cause you Jones-Taylor effect. Mainly question they ask from the Eg here. Here if unsymmetry comes, then tetragonal compression or elongation comes into existence and we say Jones-Taylor effect is there. But as I said, Jones-Taylor is not in NCERT, so less important. But once they asked one question, after that they have not discussed anything about it. So less important I will say. But still once they ask in the NEET exam. Okay. The next thing is hybridization involved in the complex of this one. Okay. NiCN4 is strong ligand, so it will pair things and make it what? DsP2 square planar and diamagnetic. There is no unpaired electron. Why pairing taking place? Because of strong ligand CN. Okay, which is true about it. Again, cobalt is +3 here, easy to see. It's argon, 4s becomes 0 and 3d becomes 6, right? 3d 6, strong ligand. 1, 2, 3, 4, 5, 6. So upper two are available for the hybridization, so it become D2sp3 and diamagnetic. So you can see what they are asking. Has 4 unpaired electron? No. Wrong. 4 unpaired? No. Non-paired, okay, and will be in high spin complex? No. Non-paired electron and will be low spin complex. That's why fourth option right. Okay, easy, just from NCERT. Among the following complexes, one which has 0 crystal filled stabilization energy. Okay, let us see. Here Fe is +3. Fe +3 means argon. 4s to become 0 and 3d become 5. Let us see now. Water is a weak ligand here. So 1, 2, 3, 4, 5. If you want to find here the CFSC, you will see minus of 2 by 5 into 3 electrons in T2G plus of 3 by 5 into 2 electrons in EG into delta node plus XP. No pairing here, so this part becomes 0. Here also 0. Total is coming how much? 0. So CFS is coming 0 here. Okay. The magnetic moment will be shown by one among the following. Okay. 1.73 means how many unpaired electrons? Here 1 unpaired electron. Okay. So in this case it is DsP2 and you will see it will have 1 unpaired electron. You look better here. Copper +2. Configuration is argon. Here it is 4s become what? 0 and 3d how much? 9. It will have 1 unpaired electron. It is some special case. DsP2 and one of the electron will go to the higher shells. It have very special type of structure. Okay, I don't think it is very much important for us, but yes, it will have 1 unpaired electron and is DsP2 hybridized. Its electron will not remain in the d orbital, it will go to some higher shells and here it will have DsP2 and in the next p our 1 electron jumped from here 3d to next 4p it jumps, right? This type of diagram you will see. It is DsP2 and 1 electron come here. Very rare case, right? it is dsp2 here, it is dsp2 here and have one unpaired electron. This electron jump from here to here. Okay, a special case. We were expecting that if it is d9, it should be here only, it should be sp3 hybridized, but no, it jumps here and it is what? dsp2. One unpaired is present here. In which one? It is 3D. Which one? 4s and which one? 4p. Iron carbonyl is definitely beta mononuclear. There is only one center, na? Clear? It is mononuclear. Very easy answer. The longest CO bond. Okay, see carefully. When metal and carbon will make a very good synergic bond, metal carbon bond becomes strong, but the carbon oxygen bond become weak, right? Because of synergic bonding. In this case, if you see how we check these questions, NEET question only. Fe have how much charge? -2. More the negative charge on Fe, good the synergic bonding. I am saying more the negative charge on metal ion, synergic bonding become very strong. Means bond order of metal carbon will increase, and that's why the bond order of carbon oxygen will decrease, and that's why the bond length of carbon oxygen bond increase. So more the negative charge on metal ion, better the synergic bonding, or you will say it will make good back bond that way. It can donate electrons in very good way to the carbon in back bond, right? And that's why you see it has a negative charge, very strong Fe carbon bond. So oxygen carbon become weak and length of oxygen carbon bond will increase. Fine, right? Which among the following is used as anti-cancer in cisplatin? Just you can see in the uses of carbonyl compounds in the NCERT. Cisplatin, you can say. Zirconium and hafnium have similar size, right? We know it very well that 3D, 4D, 5D. The 4D is very large than 3D, but here size is almost same. Because of what? The reason we know, lanthanoid contraction. It's a lanthanoid contraction, or we can say poor shielding of 4f electrons. The real reason behind it is poor shielding of 4f electrons, right? So you can see here the reason is lanthanoid contraction. Or if by chance you see poor shielding of 4f electron, it is also fine. Okay, bacha. Calculated spin only moment of chromium +2. Okay, chromium +2, if you want to make, what is that? It's argon. 4s will become 0 and 3d become 4. So 4 unpaired electron are there. So 4 point something will come, right? Chromium is 4s1, 3d5. So if you are making it +2, so 1 gone from S, 1 gone from D. 4 unpaired electrons means what? 4.9 something. Easy. Now, some of the elements from the D block, they are saying some properties are given. The metal which reveals a maximum number of oxygen state. Which one? Manganese. Because manganese can show from +2 to +7. Lot of variation. The middle elements in the series show maximum variation in their oxidation state. The metal, although placed in a 3D block, is considered not as transition. Zinc, cadmium, mercury are non-transition elements. In 3D series, which one? Zinc. The metal which does not exhibit the variable oxidation state, which one? Scandium. Scandium show only which one? +3, no variation. Zinc also I can put in this category. Zinc only show which one? +2. So scandium and zinc do not show a lot of variation in the oxidation state, or I will say they don't show variation at all. The metal which show +1 oxidation state in aqueous solution undergoes disproportionation. Very important, copper. If you have copper in aqueous solution, it gives us copper +2 and copper. copper plus 2 become more stable than copper plus 1 in aqueous state because of its very high hydration energy, which even compensate the second ionization energy of copper, right? The next thing is again about the magnetic moment they are saying, easy to find. You can see how many unpaired electron it is. The formula I am writing, it's under root n into n plus 2 Bohr magneton. One example I am giving. If you say in terms of, this is mu. You show it in mu, the value comes in Bohr magneton. If I am saying cobalt plus 3, cobalt plus 3 is what? Argon. 4s to become 0 and here 3d6. If you fill 3d6, 1, 2, 3, 4, 5, 6. So how many unpaired electron? 4. So definitely if I put here 4 into 4 plus 2 under root 24 Bohr magneton, right? This way you can find easily. We have done many questions on this basis, so you can find. Now HgCl2 and I2 both when dissolved in water containing I minus, okay. But first of all, so HgCl2 combined with I2 and give us HgI2. Then this HgI2 further react and make complex here HgI4 2 negative. Maybe you have seen this way sometime, K2 HgI4 Nessler region, right? In testing of ammonia we can find this. And one more thing here, I2 combined with I minus to become I3 negative. So finally give us HgI4 negative and I3 minus, right? Just reaction based question. The next thing is, which among the following process does not involve oxidation of iron? Okay, here you see, here Fe0 and it makes a complex FeCO5. Here Fe0, here also Fe0. There is no oxidation of iron. That's why you can say there is no change in its oxidation state. Fine? Okay. The magnetic moment they are asking 2.84 means it should have 2 unpaired electrons. Fine. If you look at the beta nickel plus 2 argon 4s 0 and 3d 8. If you fill the d8 here, you will see 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electron means magnetic moment will be around 2.8 or 2.9 something. They are giving 2.84. Remember, do not solve the root. By chance, it is coming n into n plus 2, where n is number of unpaired electrons. So you can directly say, if a 4 unpaired electron, then 4 point something is the magnetic moment. 3 unpaired means 3 point something. 5 unpaired means 5 point something. Okay, directly you can answer without wasting time. Okay. Because of length and contraction, which among the following have nearly same size? Okay, we know zirconium, hafnium. If you remember, it is titanium, zirconium, hafnium. 3D element, 4D element, 5D. It large in size, but these are approximately same. Length and contraction. Okay, easy question again. Okay, which among the following statement about the interstitial compound is incorrect? Okay, interstitial compounds are very much inert in nature or very less reactive. But what they are writing here, they are chemically reactive. This is wrong. Interstitial compounds are inert in nature, very hard and very high melting point, but they retain conductivity similar to the matters only. So they are inert, not very much reactive. That's why this is wrong. The neutral or faintly alkaline medium, KMnO4 oxidizes iodine to iodate, right? Okay. If I write the reaction, MnO4 minus, I minus, faintly alkaline, or neutral, it become MnO2 and I minus become IO3 minus, right? Oxygen state wise, Mn was plus 7, now M become plus 4. I was minus 1, I become plus 5, right? Whereas if you take the good thing is, if you take acidic medium, the reaction is something else. MnO4 minus plus I minus, make it Mn plus 2, acidic medium, right? And it becomes just I2. So this is difference. KMnO4 oxidize I minus 2, I2 in acidic medium, whereas in neutral or slightly alkaline, it reduce or oxidize, sorry, I minus 2, IO3 minus iodate. These two are very important, okay? The next one is identify the incorrect statement. Find the transition metals and their compounds are known for their catalytic properties due to their ability to show variation in oxygen state. Very good, no issue. Okay, now if you check here, CrO4 2 negative, Cr is X, 4 into minus 2 equals to minus 2. So X is coming how much? Plus 6. Chromate ion, dichromate ion, 2X, 7 into minus 2 equals to what? Minus 2. What is coming X value here? X is coming plus 6. So both are plus 6 only. Chromate and dichromate, chromium is present only in plus 6, which is same. That's why this statement is not right. Their oxygen state is same only, no difference, right? The magnet and permanganate ions are tetrahedral due to the, okay, if you look at the structure, if you look at the magnet ion and permanganate ion, definitely these are tetrahedral having sigma and pi bonds, and pi bonds are between d orbital of what? Metal and p orbital of oxygen, right? So because of pi bonding you can say, due to what? The pi bonding involve the overlap of p orbital of oxygen and d orbital of manganese, right? Good. Which among the following ion exhibit the DD transition? Out of these 4 ions, it's very important question, only one ion show its color because of DD transition. Remaining 3 ions show its color because of what? Charge transfer, right? If you look at this one here, in MnO4 2 minus, Mn is not plus 7, Mn is actually what? Plus 6. You can see X 4 into minus 2 equals to what? Minus 2. So X coming plus 6. So there is one d electron. There is one d electron in which electron can jump from lower orbital to upper orbital, like T2, G2, EG type of transition. So DD transition is possible in magnet ion. Chromate, dichromate, permanganate, all of these 3 ions show color because of charge transfer, but here it show by DD transition. Important question. Name the gas that can readily decolorize acidified KMnO4. Definitely, you can oxidize SO2 to high oxygen state like sulfate plus 4 to plus 6, so it will reduce, and that's why it will decolorize. Okay, same question. If you pass this from SO2, it will oxidize to what? S is plus 4 here, and here sulfur become plus 6. So oxidation of SO2 or sulfur and reduction of K2Cr2O7. Assuming the complete ionization, the same moles of which the following compound will require the least amount of acidified KMnO4. If you look here, these things have high value of N factor. Look here. Here Fe plus 2 oxidized to Fe plus 3. Sulfur already maximum plus 6. So its N factor is how much only? 1. Now you see, if I say number of mole of FeSO4 into its N factor, how much only? 1. And KMnO4 moles, I am taking KMnO4 moles, In SD medium, how much n factor? 5. Right? So I have to check where I can take its minimum amount. So what is coming? It is coming number of mole of KMnO4 is coming what? Mole of FeSO4 into 1 by 5. So its n factor is 1 only, na? That's why its moles required will be 1 only, or less only, I will say, sorry. If something have high n factor value, so I will need more moles of KMnO4 to oxidize it. Its n factor 1 only. Whereas if you go here, Fe can also oxidize +2 to +3. Nitrogen can oxidize to +3 to +5. So its n factor how much? 5. Its n factor Fe oxidize +2 to +3. Sulfur +2 to +4. So how much beta? Sorry, +4 to +6. So again n factor 3. Its n factor Fe oxidized +2 to +3. 1. Carbon +3 to +4, +3 to +4. N factor 3. Right? So lower n factor thing will need minimum moles of KMnO4 to oxidize it, right? We have proved from here also. Okay, gadolinium has low value of third ionization enthalpy. Okay, because of what? Because after losing third electron, it becomes stable, and when it becomes stable, so you can say high exchange enthalpy will be there. So if something is stable, like you can say D5, F7, half-filled things have high exchange energy. So more the exchange energy, remaining energy become what? Less, and stability will increase. That way we can think. The incorrect statement about the following. Okay. Most of the trivalent lanthanoids are colorless. No, most of these are colored only, not colorless. Identify the incorrect one. Lanthanoid reveal only +3. No, these can show sometime +2 also and +4. Europium +2, terbium +4 can exist. That's what is wrong. Okay. Now, what is copper? Copper is definitely a transition metal. Fluorine is a non-metal. Silicon is a metalloid. Cerium is a lanthanoid, right? Okay. So silicon is a metalloid, or in the 14th group they are writing it is as non-metal. I told in the previous method also. In 11th NCERT they are showing it as metalloid. In 14th group they are writing it as non-metal. So NCERT is saying both way. Maybe it is having more non-metallic nature, little bit metallic. So we can put in metalloid category, but the non-metallic nature is very high. Okay. Reason for the greater oxidation state in actinoids than lanthanoids, because the you can say 5f, 60, 7s energy gaps are very less, so electrons can easily jump from one orbital to other. That's why it can show a lot of variation. Like lanthanoids can show only +3, maybe sometime +2, +4. But actinoid can show +3, +4, +5, +6, +7. So here more variation. Why? Because of the less energy gap between these three orbitals or these three subshells. Okay. Which one of the following related to the lanthanoids is incorrect? Fine. You say beta, all lanthanoids are much more reactive than aluminum. No, they are almost same reactive as of aluminum, not so much highly reactive. The electronic configuration of europium, gadolinium and terbium. Europium, if you remember, start lanthanoid, cerium, europium, gadolinium. What here? Last little bit which one? Lutetium. Right? And before that you can say ytterbium. These are the elements. These are middle elements. Middle elements have F7 here. That's why special thing about it. You see, where is F7, 6s2. This is F7, no d electron. It is F7 and D1 also. So try to find such option. It is F7 and yes, you have F7, here F7, D1 also, right? And definitely they are saying which one? Terbium F9, 6s2. Fine. Okay, good. Gadolinium they are asking again. Again, NEET question beta. What is gadolinium? This is 4F7, D1, 6s2. The reason for the lanthanide contraction, as I said before, because of poor shielding of 4f electrons, it causes lanthanide contraction, and poor shielding of 5f electrons, it is responsible for the actinide contraction. Fine. So what will you say here? Yes, it is because of the negligible screening or shielding effect of f orbitals or their electrons. You can say that, right? Okay. Which among the following lanthanide ion is diamagnetic? If you look at the ytterbium is like it is 6s2, and you can say it was 4f14, right? There is no d electron, so ytterbium plus 2 will make it what? 6s0. That's why f14, all electrons are paired. That's why it is diamagnetic. Okay, so this is it about your inorganic marathon. I hope these questions will give you a benefit in the last week of NEET. So best of luck once again. I hope all of you will do well in your upcoming NEET exam. Okay, bacha, bye. Best of luck once again for the NEET exam. Bye.